Good afternoon, guys. Can everybody hear me? All right. All right. So some of you might be wondering who's Merrill. May or may not have heard of Merrill. I'm going to talk about that in a few minutes. But first of all, I'm honored to be here in front of you to share the journey that Merrill has taken to get to CI/CD and continuous testing. Our journey started about 3 years ago. And I mean, I have been in some of these sessions where I've heard similar stories. For example, we were hearing about Walmart, how they started their journey in 2016-17 timeframe, and they started using Test Lab that got bought by Sauce Lab, and so they've had a long journey in this process. We also have had an equally interesting journey, and I want to share some insights into that. But before I do, I just want to do a quick poll around the room. First of all, Merrill is headquartered in Minneapolis. We have locations in Denver, Denver, London, New York, and potentially we'll have a center in Asia Pacific shortly. So I want to kind of quickly ask, is anybody here from any of those cities? Minneapolis, Denver, New York, London. Awesome, awesome, that's good to see that. So anyway, I'll get started. I just want to talk a little bit of a brief background about myself. Honestly, she already did a fairly good job. I'll still have a slide on that. And then we'll talk about the agenda, and we'll tell you who Merrill is and some key takeaways for you guys. Sounds like a good plan? Awesome. Let me get used to this clicker. All right, so that's me. Won't talk a lot about myself. You can see for yourself, but I work for Merrill. I've been there for about 4 years. I've had some background in software development for about 25 years. I also do some volunteering at some school districts in Minnesota. I'm also a painter, as an amateur painter. So any painters in the house, I would love to connect with you, anybody who has an interest or a passion in it. As a thing, I'm trying to network with people anyhow, whether or not it's sauce related. All right, and then before I forget, there's somebody else I wanted to introduce. His name is Suresh Alokam. He's my QA manager and an automation architect at Merrill. Done a fantastic job of setting up an automation framework that I will be talking about shortly. So Suresh, if you're in the audience, I know you are, just wave at people so people know who you are. Awesome. So with that all said, I'll get started. So here's the agenda. Who is Merrill in Dataset 1? Talk a little bit about that. What are our testing needs? Why we chose Sauce Labs? Some of you I know have talked personally are in the process of figuring out whether to use Sauce Lab and what the value proposition is. So maybe that'll be a good thing for you guys to hear about. What our testing structure looks like. And then we'll talk a little bit deep dive into the automation framework we have implemented and some key takeaways. And since the takeaways will come at the very last point, and I don't want to lose a lot of audience, I'll give you a little sneak peek on some of them so that have you interested. We're going to talk about how we achieved maximum parallelism in automation scenarios, and then how we use API calls for our test data setup and teardown. And also we'll talk about how we decide which test cases to automate. It's always a dilemma. Many companies go through the process of trying to move from manual testing to automation testing. And there are certain tests that should be automated, some should not be automated. And how do you make the best choice? Is there a logic, a math, an art, or a science around it? We have struggled with it, and we have come to a point where we feel like we understand this a little bit, so I want to share some more about that too. Okay, moving on. So who's Merrill? Is it this company? Is it this shoe company? It is not. I wish it was. We would have lots of good shoes to wear, but it's not the shoe company. Is it this company? Merrill Lynch? Nope, not that either. So then who are we, right? We'll talk about that in the next slide here. But anybody here heard of Merrill before I even say it? Because, obviously, Suresh, you're exempt from that one. But anybody else, then I would probably tell them to close their ears. But anyway, we'll go to the next slide. Who is Merrill and what is Dataset 1? So Merrill is a technology company. It's also referred to as a financial services company in the due diligence space. So in layman's term, if you think about it, it's a platform that companies use for mergers and acquisitions and IPO offerings. So our competitors, we have a few competitors, but Merrill has been in business for a long time, and the initial days it started off as a printing company, and then they moved into a physical data room where company A, trying to sell their company to company B and multiple buyers, they would go to a kind of a location off-site, right? Remote location, secret location, so nobody knew about this happening, and they would spend days with lawyers and investment bankers and others and figure this out, and then finally make a decision, and then it would become public knowledge. So they started off that way, and then they decided that there's a niche area. We could create a virtual data room, a secret, or I shouldn't say secret, a secure place for this to be set up so that you can share your documents, you can do analysis of what you want to do, and then eventually come up with a decision. So that's what Merrill is involved in. We also do, we're talking about the same thing I just said, mergers and acquisition business, right? Secure place to store. And our flagship product is called Dataset-One. And we obviously have businesses in US, Europe, Asia Pacific, and we're continuing to grow. Got a little plug for myself here. If we're hiring at those locations, if there's an interest, please feel free to reach out to me. So that's what Merrill is. Merrill is a company, Dataset-One is our flagship product. So what were our testing needs? So 3-4 years ago, we had a 14-year-old technology stack, pure Java. There were some other components in it too, obviously, but we didn't get a chance to do a lot of innovation and modernizing that stack for obvious reason. And then we decided to not go down that path because obviously we wanted to have a very modern stack where we can push changes into production much faster. For example, we were pushing code to production every couple of months or quarters, and we want to get out of the model. We want to have a modern stack which would allow us to have a higher frequency of production push. We want to adopt agile methodology so we can have sprints of 1 or 2 week cycles. And then we had to embrace DevOps practice and also embrace the automation engineering concepts. So that was the first thing we want to do is migrate all our applications front end and back end to a new platform. And then we want to do the production deployment every day. We want to do a 600 plus regression scenarios. We want to support those, and then 39 more smoke scenarios. That's what we kind of, in a average way, look at it. So then why did we choose Sauce Labs, right? Because we started off, actually we evaluated browser stack for a bit as well on this topic, and we ended up using Sauce Lab. So these were the main reason we chose it. One is that we wanted to automate our pipeline. We wanted to push the button deployment, and then we wanted to spin up and scale infrastructure for concurrently testing automation. And then we also needed the ability to test multiple browser operating system and language combinations because that was our business need. And then, so one of the things we looked at was we wanted to do 100% automation push to test and build to development stage, and then push button to production. And then in doing so, we didn't want to create a big data center for ourselves with all the servers needed to scale up and down when we wanted to test. So Sauce came in really handy because they have this infrastructure and they can easily scale if you needed them to scale, right? And we also wanted to test with multiple browsers, which, as you all know, the browsers versions change, the features change, and keeping up with that is quite a mess. We also have mobile applications, which we haven't actually looked into that aspect of Sauce yet, but that's another area where having your own test farm is kind of a little cumbersome. And so Sauce Lab was chosen because they actually have a cloud-based test execution environment, and they can spin up multiple VMs, and you can have multiple threads. You can run tests in parallel. So it became a natural choice for us to at least try it. And so we've used it for 3 years now. We really like it. We're using other features of Sauce that are getting implemented. For one of the things that we're doing is they had data centers in US. As far as I understand, they have 2 in East and West Coast, I believe. But anyway, they recently started their EU data center, and we are taking advantage of that because we have lots of customers in EU as well. Anybody here uses the EU data center or has started using it? Don't see a lot of hands there. So, but anyway, it was a new feature that they just started, and we took advantage of that, and hoping to continue to use the new features that get rolled out from Sauce Labs. So, moving on, this is our testing structure, right? We support 3 environments, dev stage, and production. We support 5 browsers and versions. We support 14 international languages. We have we've got 11 feature squads or scrum teams, and that they're geographically distributed. So our QA folks work in all of these squads. And then we also have 4 dedicated QA engineers and 10 manual and automation engineers. That's our structure. Oh, sorry, that's the last one. QA works in a very strong and tight CI/CD with a quality gate at every code merge. So let's talk about the framework. This is going to be a complicated slide, so bear with me. I'm going to try to explain as much as I can here. So first, there's all these environment configurations, right? Environment parameters, credentials, APIs. We have details of the operating system, whether we're going to run on Mac or Windows, whether we're going to run on a browser, on a Chrome, Firefox, Safari, what application environment we're going to run on. Is it going to be prod, stage, or development? What API hosts we are going to run with, right? Again, prod, stage, development. And what source information, credentials, and data centers are we going to run on EU data center or US data center? All this information are stored in these environment configuration files. So based on the test job configurations, these are picked up as parameters, and then they run with those things. So our framework uses these as our environment parameters. And so what are the page objects? Page objects are those, they're defined as the object repository YAML files. Give me 1 second here. I'm trying to get my, oops. All right, well, that's fine. Bear with me. My notes are unfortunately not showing on the screen, so I'm trying to catch up with it here. So while I do that, there we go. So I've got the page objects, right? We talked about that, and then there's these API libraries. They contain all the API REST endpoints that we need to run for our application data setup and teardown that I'm going to talk about shortly. And then all the language libraries. So like I said, we support 14 languages. So we have set it up such that the language libraries connect to our GitHub repository, the I18 and repository, and download all the test data files, right, for that language, and then we run against that. And then we have our test data set up either in YAML files or JSON objects, or some of them are in Mongo database as well. So moving on to that, these are all stored in GitHub. Then we have the test data set up. These are in Cucumber feature files. So I don't know if you can see it, but this is the kind of like the file directory of how these are set up in our environment. I didn't bring a live environment to demo. That would take a lot more time. But realistically, what happens here is that there's a test data setup and a test data teardown that happens. So these are before and after hooks that we have implemented, and I'll get into more details of how we've implemented them in the next slides. And the tests or step definitions are done with Ruby, Selenium, Capybara, and some JavaScript. So I'm running into some issues here with my notes. Here we go. Okay. So then we have we use Jenkins as our CI/CD environment. So our Jenkins slaves run these jobs, and they execute all the API calls, and they run the tests on Sauce Labs, right? So that's where we figure out whether we're going to run it on Chrome, Firefox, Safari, or what browser versions, and Sauce runs it for us. We also use Sauce temp storage for our test data to keep our test data there. We also use their extended debugging. And they have a really good test extended debugging for some of you who have already used it, and then some Sauce logging. So this is in a high level how we have set up our automation framework for the UI tests that we do. Now let's see. So let's talk a little bit about our key takeaways, and then we'll dive into more details about it. So like I was saying earlier, these are the 3 key takeaways I had for you guys. One is, how did we achieve maximum parallelism? Why is parallelism important, right? If you have an environment where you're only running a few tests, it's not that important. However, if you're running a lot of tests, which many of you will eventually get to if you're not there already, or maybe you're already there, you have to think about how to maximize the parallelism, because you can't run tests all day long. And if you can't run them fast, then you can't deploy to production fast. So if those are key goals for you, you have to get to a point where you can run these tests as fast as you can and then move to the next one. So I'll talk a little bit about that. And then the other thing we do is the test data setup often takes a lot of time. In our use case, we are heavily file-oriented. We have to upload, download files. We have to do a bunch of stuff with it, permissions and stuff like that. And those take time. Think about if you have to do many tests and upload many megabytes or gigabytes of files to upload, either using a UI framework or manually, it's going to be too long. We can't actually run a test and get anything positive out of it. So we employ this method of using APIs, which, by the way, are already there. We didn't have to create these APIs because the APIs were done by our development team to do their work, right? We just call these APIs in a reasonable way, and then it becomes easy. We can just, we can do the test data and setup, and it becomes very fast, and we can move forward with the test. And then the third thing we're going to talk about is how did we automate, or which tests did we decide to automate? Because we have got about 500 plus automated scenarios for smoke and 1,200 plus for regression. We had to figure out how to do it, and these keep growing over time, as you know. And so I'll talk a little bit about that too. So the first one here is how did we achieve maximum parallelism? So let me get the whole slide up so you can see, and then we can talk about it. Again, one of those complicated slides. We use a ground rule at Merrill for our UI teams. We have one scenario per feature, right? Because Cucumber runs features parallelly but not scenarios. So we use the parallel Cucumber gem. There's a command called bundle exec parallel to run them. So if you're using Ruby and if you are running these, trying to run them parallelly, that's how you would be able to do it. And how do we make it more efficient? Well, we have about 30 to 40 scenarios. Well, what I'm saying is if you have maybe 30 to 40 scenarios, for example, you may not need to worry about parallelism. But if you have a high number of test cases, a high number of scenarios, you have to think of parallelism so you can run these tests faster and efficiently. And how do we do it? So Jenkins, in this picture here, you see that Jenkins is running both our smoke tests and our regression tests, right? And we use sauce to run them on, obviously, right? So we have these the pipeline jobs that are tagged with the smoke tag, for example, and we define how many threads we're going to provide smoke to do. Now think about it this way: we don't want to overrun our one job taking over all the threads, right? Because we have at Merrill we have taken 100 concurrent threads as our licensing model. So if you want to use it efficiently, we have to be careful about how many threads we give each job to run. Otherwise, it'll overrun, and the other jobs will wait in a queue, and then everything is going to get messed up. So the magic number in this case we had to figure out was 35. In regression, however, we do not do that. Because we have a lot of regression tests, at the time, we actually choose a time of the night when we run this thing, and we run all 500 scenarios through regression, and we shut down other jobs that are running at the time. Also remember that we have a lot of jobs that are running in dev test stage, all the environment, and they're running hourly. Some people are actually running manual tests too. So you have to keep in mind all these things that are running at the same time, and we have to provide for enough throughput to get this testing done. However, do it in a way so that we don't have to go back to sauce and keep asking for more licensing. But that's also not a feasible option for us. So anyway, I'm not going to go into a lot of details of this one, but this kind of gives you an idea of what we have set up. One thing I want to talk about is that the regression suite, we have set it up in a way that we have, for running it in parallel. Let's see if I can get my notes back up here again. So we have multiple jobs in parallel, right? So to do that, we have set it up so that we've got many suites. We have defined it for regression suites, and each suite has a certain number of threads that are running up with, and each suite has multiple scenarios. So it's we had to go through this process to figure out how best to use our maximum thread pool and get through this process of regression and smoke. And as the number grows, hopefully we can keep up with this concurrent threading, or we have to find a different model or different way to set it up. But this seems to have worked great for us so far. We've achieved maximum parallelism, and some of you might have already done as well. If not, and if you need some more guidance or help on this, feel free to reach out to me or Suresh. We'd love to help you with it. And then I want to talk about the API calls, right? So this is one of the feature files we have, for example, right? This is pertinent only to Merrill, but the idea is still the same. As a Merrill user, I want to replace the document, so I want to update the document. There's a scenario definition under it, right? So what we do is there's a before hook. There's a concept of a before hook and after hook in Ruby, and we use them. So in this case, for example, we say, you use that before hook to set up the download files image. You set up a file, create a file room, and you upload the test file.pdf, for example, in that file room. So that in turn calls our API. So this is a Ruby file we have, which actually makes a post to the API that we already have built from our development team. So what we're doing, if you think about it for a second, before running the actual test, we create the test data, and we are basically using the API call to do it instead of, and those are very fast because obviously they're being used in production for our actual application as well. And similarly, when we're done with the test, we do a teardown. We do an after hook. We call an API to delete the file room, and there is our Ruby file that goes back and does a put request to the API call to make it happen. So I don't know if anybody here in this room is using this kind of concept for APIs to set up and the test data and tear it down, but this has saved us a lot of time. And if you think about it, the number of files we upload and download, if each of them actually took a long time to upload and download and delete and all that stuff, we would not be able to do automation testing in the fashion we are doing. So we're taking this method to share with you guys how we've done it. Let's see. So this is the last piece of it. How do we, what tests do we automate? How do we figure out what is the best tests to automate? So in the slide you'll see, let me get the whole slide up here. Okay. So in this case we'll see we had to figure out a way that we can automate everything, right? Even if maybe people would have thought, let's automate everything and we won't have to worry about everything's going down and we'll have a high confidence in the tests we run. We can't do that. So what we do is, in our case, we have our product owners come up with the stories for their work that they want to get defined in their sprint, right? And they assign a business priority for it. So we know what's a high priority, which, there's a numbering system they use to create the priority. And each of the squads or the Scrum teams, they have QA team members. They go over the scenarios for those stories. They come up with the scenarios, and based on the business priority, they come up with the priority for those scenarios. So in this case, for example, story 1 had scenario 1, 2, and 3, right? And we figured because story 1 is the highest priority from business, we gave 2 smoke scenarios for that team because that was so critical for our business. And we put the 3rd scenario as a regression. The key here to think about is we are using this model to use business priority to drive what gets automated, right? The one thing to remember is that when our QA testers in the squad team, are figuring out which ones should be automated or which one should be a smoke versus which one should be a regression, they're tagging it as such, right? And they're doing some of it in the sprint. Some of our squads actually run 1 week sprint. So it's kind of hard to get all of this done and then or wait for the sprint to get completed to move to the next thing. So what we do is, this is why I was telling my previous slide, we have an automation team that dedicates themselves just to automation. So what they do is, for those scenarios that were tagged as automation and they couldn't quite finish it, they'll take it over and they'll finish the automation for it based on that automation tag. So, and we capture all this in Jira, so we are able to actually see why we did which one, right? What business priority came, which ones were done as a smoke, which ones was done as a regression, and for what scenarios, what feature files. And we've got about 1,700 scenarios that are written by the QA team. More than 500 have been automated via UI framework, and 1,200 has been done via the API test framework. So the other thing I'm going to say is, if you look at story 2 and 3 and 4, you get an idea of how the business priorities are getting done. The key thing here is that for something that is important to the business, we want to have at least some smoke and some regression. We don't want to leave any path that is not tested, right? So the balance is between what should be smoke test, what should be regression test. And then the other thing to share here is that when people come up with a bug, they find a bug in production, QA finds a bug, they feed it back to the system so that even if they missed a particular thing, a flow or a scenario, they will add it back to as a smoke or a regression. So that it doesn't ever happen that they missed it and we don't have a way to put it back into the automation framework. So this is how we do our automation. We decide which test to automate. Now, one other thing we'll say is that this has evolved over time. Obviously, we didn't come up with this plan ahead of time. Initially, we had our own logic to figure out which should be smoke and which should be regression. But you have to remember that eventually there is a concept of, many people think that once you automate something that there is nothing else to do about it. It's done, move on to the next thing. But our automation framework as well as the automation tests need care and feed. Without that, you're going to fall into the trap of always trying to keep up, and then your business folks are going to continue to push you to deliver more features, and your automation tests are going to break, and you're not going to get the advantage of this automation framework and sauce and the investment that you've made. So what we did, that's why we did this way, is that we have manual testers and automation testers in each squad, plus we have the dedicated team to look after this overall, so that they can at least take care of this. Another thing I want to share here, when we wrote our automation framework, it was written in Java. It was primarily a Java-based automation framework, and it works really well. But what we've learned recently is that many of our automation engineers we hire, they understand Ruby pretty well, but Java is not necessarily, and this goes back to what Pranav from Walmart was talking about earlier, the non-opinionated frameworks, right? There are people who don't quite like Java or don't quite like something else, and we are trying to get to a point where we want to actually rewrite our framework to use Ruby instead of Java. And the idea behind this is if you're able to do that, the functionality doesn't change. However, what it does is we'll have more adoption, because then our QA engineers can understand this better and then make changes to it, and this will continue to grow and live. So that's right. It's another thing we are doing for our automation framework. So that said, I think, let's see, forget another. Actually, that's all I had for my slides. So I might actually get done a little early here. If you guys have any questions, feel free to ask.
Okay, great. One sec.
Hello, everyone. So are you using that API test scenarios? Are you using Source Lab for that, or just a UI scenarios?
So we're using, sorry, I'm looking at the Q&A. We are using our Source Labs only for running UI tests.
Not for API tests?
No, all API tests are done from the backend from our Jenkins directly into our API framework.
Also, I have the second question. I do not know your application, but you have mentioned you have language libraries. Mm-hmm. So that test scenarios, you're counting 500. It include all the languages as well, or only one scenario for language, or multiplied by languages?
So I'm going to have Suresh answer this one. He's ready to answer, so I'm going to give him the opportunity to answer that.
So our application is supported in 14 languages. We have 39 smoke scenarios and 600 plus regression scenarios. There is a need to run smoke scenarios or regression scenarios in multiple languages whenever there are changes happen in the actual functionality, right? Because at the end of the day, functionally nothing is going to be different. It's the same thing. But when you're doing validations in a different language, when you shift your automation from English to Chinese, you need the exact vocabulary to use when you need to click on something, when you need to enter some text, when you need to do operations. So all the language libraries have built in something called I18N. Yes. Not always, right? Running automation in 14 languages is not happening every day, basically. Mm-hmm. Smoke runs every hour, regression runs twice a day, but running all this in all 14 languages does not happen every day. Only upon major changes to a particular feature or something, we run that. That's on demand. Yeah.
Now you're next.
Hi. You're using BDD cucumbers. Do you have any business people or product managers writing test cases for you?
Yeah, so No, the answer is no. I have been in other organizations prior to Merrill where that happens. That's kind of like the dreamland to be in, where it actually was very beneficial because it's a natural language, right? So there's a benefit in having that be done in a natural language. But we're not there yet. Right now, our QA engineers actually sit with the product owners when they write these test scenarios, so they're informed of it, but they are not the ones who actually write it. Does that answer your question? Okay.
Here's another
Other question? Yeah. Mm-hmm.
Yeah, basically my question is in regards to BDD. Maybe it's the same question that the other people did. But basically, are you guys really sitting together with developers, business analysts, in order to define the Gherkin file or not?
Mm-hmm. Yeah, so that's a similar question he was asking. The question was, who's writing these Gherkin files or the BDD natural language? Right now, and I was answering the same one, we are actually having our testers in the individual squads write it. They do it with the participation of product owners and developers. However, I've seen other organizations actually where either a business analyst or a product owner writes it for them. We're not there yet. And it's part of the, I think it's a learning journey for us. We might get there someday. And in fact, that's the value of it because it's the natural language. But we are definitely maximizing our advantage with our QA folks, very well informed, and then doing it with the product owners.
Okay, there is another question that I have is, in regards, what is the criteria you guys are following in order to decide if you're going to automate the scenario or not?
Yeah, so in the slide I had, where the big jumbo slide, but if you think about it, what we did was we have our product owners create a business priority, right? And we have them scale with a number. So for example, if you think about it, if you have a numbering scale, and if you say anything above 10,000, for example, if you use that number, is a business critical item for us. And we would try to make sure there's at least some automated smoke for that, right? And if not, obviously there will still be manual testing. We're not at a point where everything is automated and there's no manual. We still have the manual tests. But the way we look at it is, we definitely, for the critical business features or bugs or however you look at it, we need to have some smoke and some regression. And we define based on that numbering scheme and the QA person from that working with the product owner, which one should be smoke and which one should be regression. Yeah, you're welcome. Any other questions? There's another one here.
Okay, so in terms of your parallel executions, you said that you were maximizing to get 100% effective parallelism. Mm-hmm. But I didn't quite fully understand because you were mentioning that for Ruby, I don't have experience with Ruby, so Cucumber is working by running features in parallel, not scenarios. Yeah, and then you divide it in different batches, which are executed by Jenkins slaves.
Yep.
But how is it really? Could you like elaborate a little bit more on that one?
So I think Suresh is very eager to answer that one, so I'll let him do that.
So it's just not one thing that is enabling us to achieve the maximum parallelism, right? There are some key principles. Basically, we know Cucumber just runs features parallelly, so we made sure that one ground rule for everyone is there is going to be one scenario per feature file, so that when you're running a feature file, it's not going to take long time because it is not having multiple scenarios. That's one thing. And the other way, when we go to the regression, there are like 600 plus scenarios. Now, if I put everything in one batch and provide the thread number as like, okay, I have 100 concurrent sessions, run it at 100, what will happen is, you know the bundle execution logic on how it divides all the test cases number by the number of threads you used. It'll make many tests actually wait in the queue. So what did we do? We divided everything into 50 batches, and we created some Jenkins pipelines which are going to execute set of 3 suites actually. And these 3 suites run again in parallel. So 3 suites means that's almost like 150 test cases, and the wait time reduces. So there is a little logic on how you divide your tests into multiple suites and how many tests you induce into each of these suites and how did you build your pipelines.
So basically you're using different set of tags within a single feature?
Yes. 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 Yeah.
That was actually a really good question because we didn't come to that very easily, and we had to come up with a really good way to separate it out and do these test executions. So good question.
Okay, if you're running several thousand tests a day, which it sounds like you're doing, what happens when tests fail and what happens when a lot of tests fail?
Our success rate is, our success rate is almost like 99%. The 1% failure rate when we see is like when we are running the regression cycles, right? Regression has more than 600. Someone said today morning that 10% of the tests might fail, right? But it's not like that. There might be 10 or 15 out of, or the entire suite fails because the source labs is down because of some crazy issue that they have. So what happens is, every PR gets tagged. I mean, there is a lot of mechanism over there. Smoke runs and it verifies the code and it tags the code in dev and it tags the code in stage. This is automated process. Until stage, we do not do anything. The code automatically gets in there. But after stage, for us to do a daily deployment, one QA engineer is going to push the button. When does he push the button? After the regression is run in the midnight, he'll see how many tests fail. He just rerun them. If there is an issue, we report the issue, we wait for the fix, and we just push the code into the production. Otherwise, it's all cakewalk. I mean, if it is successful, we'll just push the button to push the code into the production.
I want to add one last thing to that topic. He said, tests are bound to fail, right? Especially if that many tests, it is bound to fail. In our case, we use retry logics so that we don't just, a goofy thing happen in network and fail. We don't want to just have a false positive. So we do the retry logics. We also do another thing I didn't get a chance to talk about it, is we parse the output of the Jenkins jobs when whatever happens, right? And then we parse it into a kind of a definable format, and then we actually send it to our Slack channel where people are watching for it, and we page people. So depending upon the severity or the threshold that we set for it. So yeah.
Thank you, Anesh.
Yeah, thank you guys.
So if you guys wanted to keep your seats, our next session is at 1:50. Wizard of Oz testing, which is USA Today News Network hosted speaking opportunity and panel. And a round of applause to Anesh for doing a fantastic job. And thanks, everybody.